We are going to flip our classroom today. We started 6-1 notes on Friday, but with being at only 20 minutes, we didn't have that much time. So I have all of this on video, and you have the opportunity to watch it this weekend. On Monday, we are going to work in class on the worksheet, a homework assignment, and then you can also finish 6-1. When I help you on Monday, I'm going to refer to your notes. So if you don't take notes on this, I'm going to tell you, well, then you need to refer to your book. So if you're going to have questions on how to do any of these type of problems, I need to make sure I take notes on those things. At any time you feel you need to pause the video to write something more down, or if you need to rewatch the video, please do at your own pleasure. All right, in chapter 5 we talked about the definition of degree. A degree can be measured 360 degrees all the way around a circle. You also learned in geometry 180 degrees is halfway around the circle, or a straight line. So actually the definition of a degree is 1/180th of a line. In this chapter, we're going to deal with radians. That is a different way of measuring an angle. Kind of like when you're measuring a length, you can measure in inches or in feet. Well, in degree or in angle, I can measure in degrees or in radians. Okay? The definition of a radian, it's like finding the circumference on the unit circle. So if I'm finding the circumference on the unit circle, the circumference would be 2 pi r, which is 1 on the unit circle. So the definition of a radian is 2 pi radians is the same thing, again, all the way around as 360 degrees. That ratio can be simplified to 180 degrees equals pi radians. We're going to do a couple of different things today. We're going to start off and just do some conversions so that you can compare them. I would strongly suggest not converting from degrees to radians and radians to degrees back when you're actually solving the problems. Because if you have to do that, calculus is going to become nearly impossible, and so is graphing the rest of this chapter. But I do want you to understand that those are two different measurements. So again, like whenever you're converting something, if I want to take 115 degrees, and I want to change that to radians, I'm going to multiply by 1, but I'm going to use that conversion ratio. And we just said the conversion ratio is 180 degrees is 1 pi, 1 pi or pi radians. So I'm going to put the degrees on the bottom because I want them to cancel, and I'll put the radians on the top. So my degrees are going to cancel. I'm going to be left with radians, and my answer would start off with 115 pi over 180 radians, but I do need to simplify that. Okay? If you always would like to, you can use the fraction button on your calculator to simplify. You can also know that 5 goes into both of those numbers. Okay, and then you should get, when 5 goes into both of those numbers, you should get 23 over 36. The one thing I do want to warn you, radians is always written as an improper fraction, not a mixed fraction. So even if you get a mixed number on your calculator, you have to change it to that improper fraction. Okay, so these two are the same measurement. One's just in degrees, so here's 115 degrees. There's 23 pi over 36 radians. They're the exact same angle, just written two different ways. So negative 7 pi over 8, that is in radians. So this time when I multiply, I want radians to be on the bottom so that they will cancel. I'm still going to use this same conversion. Pi radians is 180 degrees. There are two things that are going to cancel in this case. The radians and the pi. So when I go to simplify this, I'm going to have, and I'm going to write it this way, negative 7 times 180 over 8. and that's in degrees. I can simplify that because I know 8 and 180 have some common factors. They both have 4 that goes into them. Okay, so I'll be left with 2 on the bottom. 180 when you divide by 4 is 45. So I'm going to take 7 times 45. Now again, you could use your calculator, and in degrees, it's okay to write that as a decimal. So if you want to write it this way, or 157.5. Now, this is a very common mistake when we go to write it as a decimal. I forgot that negative, so don't forget to check. If it's a negative, that tells me the direction. So this is still going to be negative. Okay? Now, the unit circle. In chapter 5, we learned to use our special triangles and be able to find all the trig values. Now we're going to do the same thing, but in radians. Here are some keys that would make it very easy, conversions to memorize. Okay, 30 and pi over 6. Now you'll notice, and I have this in color on purpose, 30 degrees has the same reference angle for 150, which you'll notice also has a 6 on the bottom, 5 pi over 6. And 210, which has that same reference angle, also has a 6 on the bottom, 7 pi over 6. And if I keep going all the way to 30, the same reference angle of 30, that also has a 6 on the bottom. So you can check those conversions, but these are the same measurements. So whenever I have a 6 on the bottom, I know it's going to have a reference angle of 30. Whenever I have a 3 on the bottom, that's going to have a reference angle of 60. And whenever I have a 4 on the bottom, that is going to have a reference angle of 45. Of course, these have to be simplified. For example, 2 pi over 6 can be simplified to pi over 3. So that wouldn't be a 6 on the bottom. I would always simplify my fractions first. And then the other ones, besides knowing those triangles, I also need to know my quadrantal angles. Now remember, 180 is pi. So if I go halfway, half of pi is pi over 2. So you'll notice every half pi is a new quadrant. Pi over 2, pi, 1 pi, 1.5, or 3 pi over 2, 2 pi. So if I wanted 5 pi over 2, that would be here, 6 pi over 2, 7, and so forth. So again, as a cap, here's what I need to realize. Anytime I have a 6 on the bottom, that's going to be a 30-degree reference angle. I need to key that into my brain. Same thing with the pi over 3 and the 60, and the pi over 4 and 45. Anytime I have a complete pi, that's going to be on the x-axis. Anytime I have half a pi, it's going to be on the y-axis. Here is one part that some kids are really going to struggle. You have to know what quadrant it's in also. So I have to know how to draw those values, and I'm going to give you some hints as we go through this. So starting with this first